Welcome to the talk about unit testing best practices and horrible mistakes. Or as my American friends like to say, good practices and possible mistakes, because they don't like to hurt other people's feelings. And I agree. Most of the things we'll talk about are possible mistakes. They're only a single specific point of view. But I'll try to explain as much as possible why do I think these things are possible mistakes. A little bit about me. I wrote a book in 2006 called The Art of Unit Testing. It's going to come out in the second edition. And when I started that book, I had 0 kids. But when I finished that book, I had 2 kids. And by the time I finished the book, it took 3 years, I realized just how wrong I was and how the things I wrote in the book are already wrong. So I had to rewrite some of it. But for the second edition, basically, I actually went to Goodreads and I marked my book as 3 stars because I think some of it is wrong. So I hope the second edition will fix some of that. I'm actually in the process of writing another book called Beautiful Builds, and I just had a book about Notes to a Software Team Leader published. But most of all, if you have any questions or things after this talk, you can feel free to just ask me via Twitter or just contact me in some way after the presentation. And I want to say that everything that you're going to hear are based on my actual failures. So I failed quite a bit. I think Chad Fowler would have been proud. And a lot of those failures taught me so much that today in projects, I can kind of get the projects to work and have unit testing actually succeed in our project. I'm quite nervous. This is quite a big crowd. That was a joke. Now, the first mistake is that people believe that just by doing it, unit testing will make your life easier. You hear it in everyone who talks about unit testing. Unit testing is amazing. Unit testing will make it easier to find bugs. So imagine that. When you have 4,000 unit tests in your code, it's easier to find bugs. Well, that's absolutely wrong. Most of the time, what happens when I come to projects and do consulting is that the tests themselves have bugs. The tests pass when they shouldn't be passing. They fail when they shouldn't be failing. And so there is no trust in the tests. So how do you make sure that your tests don't have bugs? Do you write a test for your test? How does the test for your test, how do you know that doesn't have bugs? So writing a test for the test for a test doesn't work, I can tell you that. Now, one way to solve it would be test-driven development, in which we see the test fail and then we see it pass without touching the test. So we're actually testing the test this way. But most projects, it's actually not easier to find bugs unless you pay close attention to what the hell is going on in the code and the tests. And we'll see how to fix that. Another thing that everyone says is that it's easier to maintain your code when you have something like 1,000 unit tests, 4,000 unit tests. And again, that's absolutely not true. Because the tests, if they test a lot of internal implementation, what you end up with is that you refactor your code, and then suddenly you have tests breaking, even though they should actually be passing, if the code still works. And so you have to go and start changing the tests. And at some point you start saying, you know what, this isn't worth my time. And then you start removing tests, or actually commenting them out, or putting ignore attributes on them. So that's not necessarily true. And I would say that most projects that fail with unit tests, it's because of the maintainability issues. One of the first projects that I've had, we had to delete some of our tests after just a few months of code. It's easier to understand your code when you have 1,000 or 4,000 tests. Well, I know that that's not true. For most of the tests that you've seen, most people, especially when they start out with tests, what they see and what they think is that the test code is not as important. So they just give out names like, just test 1 or test add or test whatever. And then the test code itself is just, just assert on the thing and be done with it. And then the tests end up just like you treated them, which is they don't help in terms of readability. So we'll talk about readability issues today as well. But only when these three things are true, it's actually easier to develop your software when you have unit tests. And most of the reasons to do with why companies do not adopt unit testing into their organization is because they're failing with one of those, at least. And then that affects the other two. And that creates a very big chain reaction. The second big mistake is that once you've started doing unit tests, you do not do any test reviews or code reviews. So some companies do actually do code reviews, but most developers that I know do not do test reviews. So they review the code, but only some of it, and only at specific times. But the point of a code review and a test review is that you teach and you learn about practices. So you might have one person who really knows how to write good unit tests in the team, and that person is just writing there. He's just sitting there coding awesome tests. But then everyone else around him is just create a pile of manure around. So when you come and see the test, you see a good test, and then right below it, a test that has no business being there. And there is very little communication about the quality of the tests. So test review is one of the best ways to actually institute code reviews. Because if you think about it, tests are really mini use cases of your code that you can drill into. And you can actually understand very, very quickly whether the developer actually understood the requirement or not. Sometimes just by looking at the name of the test, you can actually understand that the developer did not understand the requirement. You don't even have to drill into the code. You don't have to read 50 lines to say, oh, no, you're doing it all wrong. Sometimes if the name is good enough, then you've saved all that time. And when you do code reviews and test reviews, it has to be in person. You cannot use a tool. If you use GitHub to do reviews of the code and all you do is in comments, yes, that's good, but it's nowhere nearly as powerful as pair programming with that person, or actually even doing remote desktop or anything like that, where that person can see the expression of your face, where you can hear the tone of their voice. A lot of information is lost. If you ask the person something and they hesitate, that's something that doesn't go through in comments. If they keep fixing their answer while saying it, that doesn't go through when they write text. You only see the end result. So you can tell where there's things that they're weak, their knowledge is weak on, and you can help them learn something. Or even better, you learn something from them. Why did you do that? That's something that maybe you wouldn't have written in a comment on GitHub because it was just a little thing. And it has nothing to do with the current code review. But you just saw that and you would have liked to say, hey, what was that little thing you just did? Or that you wrote there. But that's not about what you're doing, and then you don't write it in the comments. And maybe it's too large to start writing the text about it in the comments. And so a whole opportunity for learning something new is lost, a new technique. If your team is learning and not doing code reviews and test reviews, I would highly suggest that you start doing it. If you decide to do it on all the code, everything. No broken windows, no line of code should go unreviewed. Even if it's a single line of XML somewhere, should get reviewed, no broken windows. Because if you do, you up the bar and then tomorrow someone said, oh, it's just one method, it doesn't really need to get reviewed. But if you're trying to teach your team how to do unit testing, that's one of the best ways. Now, the things I want to talk about, they have to do with those three pillars of good unit tests. That they're trustworthy, they're maintainable, and they're readable. If you don't trust your tests, and you see them fail or pass, you might still want to go and debug your code if they pass, or if they fail, you might still say, no, it's okay. And one of the points of trusting your tests is that you should be worried when they fail. So someone said, oh, that's RTF, but just make them RTM, right? RTM tests. But if you just make them fast, it will be RTFM, and then everything is great. And I thought maybe I should add the fast then later. Okay. One big mistake is that people use mock objects and stubs for everything, when instead, they should actually be using them very, very little. So I would go far as say that maybe 5% of your code on your test should have a mock object. And when I say mock object, I don't mean a stub. And the difference between a mock object and a stub is that a mock object is something that you will verify against at the end of the test. And a stub is just something that makes happy noises. You might have multiple stubs in a test, but you could have usually only a single mock object, because it tests a single end result. Let me be a little more clear about that. When we're talking about unit tests, when I say the word unit in a unit test, what I mean is a unit of work. I don't mean a method. I don't mean a class or anything like that. What I mean is that there could be multiple methods or even multiple classes running in memory, and they get invoked by some public API somewhere. But then the test invokes a public API, and then many things happen in memory. They do not touch the file system or a database or anything like that. And then at the end, there is either one of three possible end results. You might get back a value, right? Methods that return something. You might have a void method, and then the void method has to do something as well, right? Void methods don't return values, but why would you call them? They must be doing something, and that is usually to change the state of the system, a noticeable state change in the system. And the third type of end result is when they don't change the state and they don't return a value. Why would you have such methods? When you forward calls to a third party, like some kind of logger or web API. And only in that third type of end result do mock objects actually make any sense. That's the only time where you have a fire and forget into an external framework. When you try to test on a third party without a mock object, there is very little way to check that you called Twitter the right way, etc. So if you try to assert against it, it will be really, really difficult. So instead, what we'll do is we'll have a mock object that looks like the Twitter, either not Twitter API, but a facade that abstracts it away. And if that was called, everything is good. That's the only time where mock objects actually make sense. But since the beginning of mock objects in unit testing, people have been abusing and using them much more just because they could. And that has then created a lot of tests that are very brittle, very hard to maintain, that would break on every little change to every internal implementation in the code. So 5% is maybe the amount of calls that you have to external APIs in your code. That's how many mock objects you should have. But remember, this is only a fire and forget scenario. If you fire something and you get something back, that doesn't always mean it's a mock object. It could still be a stub. It depends on the flow of information. So only if the absolute end result is calling a third party, it makes sense to use a mock object. Now, another very, very common mistake that I see is that people say mock this, mock that. Everything is the word mock for everyone. But there should be a differentiation. Now, if you read the book XUnit Test Patterns, you've seen all these things: test spy, test double, fake, mock, stub. And all these things mean something for all these somethings that look like other somethings. And that's a very, very complicated thing, especially for someone who's relatively new to this field, to understand. And what I find is that if I use a simpler terminology, and I don't use all these, I just have three things that I talk about. I have fakes. Fake is everything that looks like something else. And then if I assert against it, then it's a mock. If I don't assert against it, it's a stub. And that's the only differentiation. If you take this coarse-grained differentiation, you can start talking about the difference between mocks and stubs and not call everything a mock. Instead of saying, I'm going to mock this, I'm going to mock that, usually what you mean is, I'm going to stub this, I'm going to stub that. The only time you should say, I'm going to mock this, is when you are expecting this to be called. But even frameworks use the word mock too much. And mock is very, very overloaded. And again, the differentiation is you only want one mock per test, because you're testing one thing. You could have multiple stubs, so you need to know the difference. Third, state-based. One of the nice things that happens is that if you don't use mock objects, you're getting into very simple test territory. Sometimes it's just invoking a method and then checking that some state has changed. But you can even get that a bit into some problems. For example, you might be checking that an internal state has been changed. So imagine that white line being the boundary of your API. And the test that invokes the public API should only be asserting on an API at the same level, no level deeper. Because if you do, you're bound to get weird things. For example, look at this test. It adds a user in memory, creates a user, and then checks that there is an internal field somewhere that has the user in memory. Now, this test will pass, but it doesn't mean that the code works. Because you're checking internal implementation, what's going to end up is that maybe the other methods that have to use that user are using it wrong, or they're using a different field. So even though private implementation works, doesn't mean that the unit of work actually works from the same level of the public API. This is a better implementation of the same test. If you could do that, create a user manager, add a user, and then check that you can log in with the new user. So noticeable state difference in this case is that the behavior of the object or the system under test is different than it was before you changed the state. Either a method returns a different value, or a different method returns a different value, but it's still at the same level of the API. It's not checking internal implementations. One of the biggest problems that I see, and I talked about this, is that people do not trust their tests. And one of the biggest reasons for that is that people mix unit and integration tests together in the same suite, and they run them all together. And then integration tests are usually much more coupled to the current implementation of the local machine. For example, they need some kind of configuration. And what do we want? We want to determine that, in this case, unit tests are lightweight tests. They're repeatable. You can easily rerun them with no reconfiguration. They're fast, because they don't touch any kind of I/O, hopefully. They're consistent. They're always the same test. So if they're using datetime, the current datetime in the test, every time you run them, they're actually a different test. They might return different results. If they're using random numbers, every time you run them, they're a different test. And the point of these lightweight tests is not to make sure that everything everywhere works, but to make sure that you have a baseline of working software. You can then fill all the rest with integration tests. And they should be easy to write and read. Usually, integration tests need a lot of configuration, and you see a lot of magic, like, where did that come from? I have no idea. How did you know that that thing actually exists somewhere? So to accomplish all these things, tests need to have full control over their dependencies. That means that if you have some kind of third party, you create either a stub or a mock object. And they should really be in memory so that they can be fully consistent. I'm going to give you an example from an open source project called OpenLayer. When I got the latest version of OpenLayer and I just ran all the tests, this is what happened. You can see a lot of green, but then you see some reds. And the problem with this is, you would expect a project that has tests that all the tests would be passing. So imagine a programmer in your team that's getting the latest version of your source code, then they run all the tests, and some of them are failing. I'm sure that has never happened to any one of you in this room, but it has happened to me in some teams. And then what's the worst thing that you can hear someone say when they ask why those tests are failing? Don't worry about it. It's okay. It's just a configuration issue. It's okay. And then those red tests become just an annoyance instead of something to worry about. And the big problem here is that you don't know which tests are integration tests and which tests are unit tests or lightweight tests. If we had a separation into a different project, we could have easily said that we have a safe green zone. Tests that should always be green no matter what. And then we have some confidence, and if one of them fails, we should actually be worried. But because they're mixed, we tend to stop doing whatever configuration we need to just get those things to pass, because we have better things to do with our time. So by separating, we at least give some sort of confidence and some sort of safety. and more trust, at least in some of the tests as a group. jQuery has the same problem. When you get the latest version of jQuery and you run all the tests by default, you get this. Well, actually, you get this, but if you run it again, it takes 7 minutes, by the way. If you run it again, you get this. Okay, so it was 137, now it's 136 failed. What the hell does that mean? What am I supposed to think? Does it mean that jQuery has bugs? Probably not. What it does mean is that if you start digging around and start to look at all the tests that are failing, you're going to start seeing things like this. Oh, you require PHP and a server running locally to be able to run the Ajax-related tests. Makes sense. But then these are not unit tests. But all those tests that require PHP are in the unit folder of the tests. And there is no way to easily run just the unit tests of jQuery. So I had to start looking around, and of course, I thought, does that make sense that you have to have PHP running? And of course, Google will tell you, yes, you need PHP installed, etc., to get jQuery working. Not just installed, you need a server running with PHP and those files being served up. And again, you have the trust problem. If I wanted to do development, this is an open source project, so I'm comfortable with the fact that I have to set everything up and make sure that everything is working before I do the first thing. But if this was a team, if this was a project in a team, in a company, I would not expect that there to be that kind of separation, of non-separation. I would expect to at least have a safe green zone that says, these are all the unit tests that should be passing no matter what, no matter what. If we want to trust our tests, we have to remove logic from our tests. So this is an example of logic. Again, these are tests from jQuery. This is a test that actually generates a very, very long string, and it has a loop. And obviously, that seems very, very innocent. But the point is that this is a broken window. Someone else looks at this and say, OK, it's OK to write loops. Right? And then later, what's the point of logic is that if your tests have bugs, it's very hard to find. Any piece of logic in your test is destined at some point to possibly to have a bug in it. So I want to avoid that. Unit tests should just be very, very clear, simple statements. I can save all the loops and the random numbers and all that stuff, and I put them in a special folder called integration tests. Those are all the things that either require logic or anything else. By the way, there's something else interesting here, is that if you look at the top of the test here, there's a number, and that's the number of a bug that they fixed, because there was a problem. And when I have those bug fixes, especially when it's hard to recreate or they require special attention, what I like to do is that I separate those tests that recreate bugs to another special folder called bug fixing, or something like that. And in that special folder, you can have all these crazy animals, because obviously that's the only way, or that's one of the only ways you can recreate this bug. You have to have a really long string. You might read it from a file, you might generate it, you might have it in memory. You still need that long string, and it's still going to either hurt readability or the maintainability or the trust of the tests. So I put them in a special folder, and then all those tests, you're allowed, in a way, to have these broken windows, because that's a different building with different windows. But the safe green zone and the lightweight test should not have any broken windows. Here's another example from a different test. This is checking about the percentages of working with CSS in different browsers. They even put a comment. Have to verify this, as the result depends upon the support that the browser has for font size percentages. If you have to put a comment in, first of all, it probably should be a different test with a good name. But second, that if could also have a bug. Right? It looks really, really innocent, but even the innocent stuff, I'm sure, if you've had more than 3 days experience as a developer, you know that even 3 lines of code that look very innocent might have a very uninnocent bug. One of the things that I saw in a lot of frameworks, in the open source frameworks tests, is that there is a lot of forced assertion counts. So a lot of the frameworks, especially QUnit in this case, they support the idea that you can say how many asserts you're going to have in the following tests. And then if some of the asserts don't execute, your test will break and say, no, no, you told me there would be 5 asserts, but there were more or less. And that's, to me, I don't think that's a big problem, but it's definitely kind of a maintainability issue, because I don't, it's not that big a deal, but when I asked John Ressig, why is that? He said it's a bit of extra work, but it's good to know if the suite ever stops running for some weird reason. I think that's not a bad reason to have it, especially if, again, you're managing an open source project and you do not know all the people who contribute to your code, and you don't really trust that they will remember to write tests in a way that don't break and maybe in async way will not run or something. So maybe in that way, it makes some kind of sense to implement this. But then you look at tests that have 78 asserts expected. So saying, okay, this is getting a bit out of hand, because can you imagine adding another assert to that test and then having to go to the beginning and then add and replacing it to 79? That's like working at a very, very high bureaucracy company. No, this is the number of expected asserts. And of course, you know that when people start running this, they just counted how many asserts they think they had, and when the expect said, no, no, you have a different number, they just changed it to that number at the beginning, and they just kept adding 1 and 2 and 3. And then you have 119. That's interesting. This is just the beginning of the test, of course. And you start seeing, now we're seeing a different pattern. The reason we have 119 asserts in this test is because this isn't really a test. This is a test suite, disguised as a test method. And in that test method, we're testing all of the possibilities relating to jQuery.when. And then what happens is that developers are then encouraged, because they see the other tests, to then put new tests at the bottom of this method. And then they change the expect. So it's really a test suite disguised. And then each assert is really a different test. And then, of course, you cannot really give it a good name. You just have to give really good error messages. We'll talk about the error messages in a second. And then you have this, right? This poor guy. He just wanted to write a simple test. Still has to say expect 1. Now, in terms of readability, one of the things that are hard to read, when I was looking at the jQuery tests, I was looking at this test and I said, well, you're expecting the word blog from this thing to appear in this SAP thing, etc. But where does that actually exist? And then I had to start thinking, where is that coming from? And nowhere does it mention where the text is. And of course, once you realize it, you understand that the test runner, the index.html test runner, actually contains all the test data. And there's a shared, it's basically a shared resource. There's an HTML page where all the tests are running on. And then you have to go and you look at this page, and you see, oh, there it is. Okay. But then you realize that all the developers who write tests for this, each one of them probably adds a line to this page, hopefully. If they don't, what they would do is that they would manipulate this in memory as well. So imagine that you have 6,000 tests all manipulating the same piece of HTML. And they all have to coincide with each other. They all have to make sure that the other tests have the same state, etc. And that's kind of also could be a maintainability problem. Here's another example. Somewhere up there in the beginning of a very long test suite, there is a declaration of a variable, and then somewhere down below, there is the usage of that variable. Very, very annoying to try to read and understand that test. And then what happens is that, again, developers look at the original broken windows and say, okay, all the variables are defined at the top, because this did start out as a test method. But then more and more things were added. So someone at some point said, oh, you know what? It's 100 lines of code, but all the vars are in one place. I'm not going to do a different thing, obviously, right? So I'm going to put the var in the same place. And human psychology is the same way, right? You know the experiment. You put everyone in an elevator, all the people, they are actors, and you get one person into the elevator, and everyone turns around to face not the door. And then the person who's the innocent looks at everyone, and he turns the other way as well. Why? He doesn't know. He does what everyone else does. And that's kind of the point, is that here, instead of aiming for the pit of success, we're giving people a template of how to make the tests more and more, or less and less maintainable. Comments. I'm not talking about the regular comments, I'm talking about commenting out tests. What happens when you have these things in your tests? You can imagine the developer, no one will ever delete these things, ever. In 5 years, these comments will exist. And the reason? Nobody knows why they were commented out. Nobody knows if they will be someday commented back in. Nobody knows. What's the point? Must be important. And so it will stay there forever, not doing anything, but just making everyone ask unnecessary questions. So I also tell people when I teach unit testing is that imagine that the person who's going to read your code is a serial killer that knows where you live. You don't want them to start asking unnecessary questions. But in this case, that serial killer is going to take an axe, come to your house and start asking, hey, what's that comment about really? What about naming? Well, naming is one of the things that I think people really miss the most. In this case, we have a test for text with an undefined. And then at the end, notice that there is a message. The last parameter of the equal is what to put out, what to print out if the test fails. And notice the message. Text undefined is chainable. Of course, this is a bug fix. But then my question is chainable the bug or is chainable the fix? Which one of them is the important one? Should it be chainable or should it not? Okay? So the way I like to name my test is that I have 3 pieces of information somewhere so that the reader can understand what's going on. And I find that even if you leave out one of those things, the reader is going to have questions. And then they have to read the code of your test. And in this case, it's the unit of work or the entry point to the unit of work. And then we have scenario, which is under which conditions are we testing. In this case, the scenario is undefined. And then the expected behavior. And it should be in the name. So in this case, it would be text with undefined, and then I would either write can be chained or should not be chained. Either one. But I would write it at the name of the test, not at the message of the equals or the asserts. And in fact, I would argue that you shouldn't be writing any messages as the last parameter of the asserts. Because if the test name is good enough, you wouldn't have to. And when you see just the test name, you don't see all those messages when the test failed. You just see some of them, and then you see stack trace. But the test name is the first thing you see when you have failure. And if the test name is good enough, you might not need to see the code of your test before going to the production code and starting to fix it. Here is an example that I call the test of doom. Okay, lights. Okay, this is the test of doom right there. And when I looked at this test at the beginning, what I saw is this. First of all, 78, we talked about this. But then, remember, this is a very, very long test. At some point, you start understanding that this test is a big, big suite of tests. And then, at some point, you start seeing this. You start seeing all this stuff in this long test. And you start saying, okay, you have to start reading it first, and then time is wasted. Then you go, oh, I understand. This is a separate test, and they're doing a try-catch, because if they don't, all the code below will stop working, will never execute. Lights, please. Okay. So we have multiple tests in a single test, and that's both a readability nightmare and a maintainability nightmare. And one way to fix that is by having some kind of I don't know, separate tests for everything you test. I think that's an important thing that we can do. But it also leads to these things. At the beginning, when QUnit was just starting out, people were abusing it, and they were calling QUnit reset in the beginning and in the middle, and after each and everything that has to be reset. For example, the state. But this is really just an anti-pattern. Whenever you see this, the code is really telling you, you really want different tests to be extracted from here. By the way, do you notice there's like an equal inside an equal? That's got to be fun to debug. Okay, let's look at Backbone. Now, Backbone is also using kind of the same ideas, but here there are magic numbers. What are the magic numbers? Well, it's not 1, 2, and 3, but what the hell is -5? Remember the serial killer? They look at this and say, -5, that looks interesting, because it doesn't follow the pattern, right? And by the way, at the top, we have 6. That's the expected amount of assertions again. But here, our brain is designed to see patterns. 1, 2, 3, 5. -5. What the hell? If it was 4, I could understand. If it was -4, I might have understood. But why 5? Why did they jump 1? This is a mystery that I still have not solved. But just wastes time from the reader. So in terms of naming, let's look at handlebars in this case. Handlebars is using Jasmine. And in this case, Jasmine allows you to have nested blocks of things, much like RSpec from Ruby, etc. But this is an example of how you can have the structure, but not have a fitting style for the structure. So if we look at the names of the test here, we have describe blocks and then it array. It array, okay? And then what should happen is in the messages here. Arrays ignore the contents when empty. Arrays iterate over the contents when not empty. Well, that's the wrong way to use the structure, because now the person has to read your test code to understand what's supposed to be going on. If you want your tests to start reading like documentation, we can look at the tests in a different way. Here's how I would structure the same tests. Describe blocks, describe array, describe, then you would have a nested describe inside it. That is non-empty, and then an it inside that tells you what is the expected behavior. Iterates over the contents. And then just the describe blocks plus the its give you everything that you need to know without looking at the code of the test. The same with that is empty, it ignores the content. With index, uses the index variable. And all I did was basically take the error messages and from here and then down below the file and just use them in different places. And that gave me a much easier way to understand what's going on. Same problem with knockout. In knockout, you have describe binding dependencies. It, and then look, if the binding handler depends on an observable, invokes the init handler once and the update handler whenever a new value is, etc., etc., etc. But it's the if that bothers me here. And again, these are amazing frameworks, but I think the test could be more readable. When you have the if, that's basically the scenario, right? You have the thing that you're calling the unit of work, then we have the if, which is the scenario, and then the it also contains the expected behavior. So it's combining these two pieces of information. But then again, maybe this would be a better way. Describe binding dependency. Describe when handler depends on observable and new value available, it invokes the init handler. It also makes sense in English. You can actually read it as a sentence. And I think the authors did mean to do this, but I don't think that they knew about the possible structure that you can have and the nesting that you could do to make it even more clear. Now, there is another common problem, which is when you have setups. If you've ever used setups, this is Batman.js. In Batman.js, one of the files looks like this. They're using CoffeeScript for some of the tests. So the setup looks like this. They have a spy. In this case, the spy is a mock object. And somewhere down in the file, they start using it. The problem is that the spy created at the setup method is only used in some of the tests. Okay, so we're checking, we're basically using it as a mock object in all these places, right? We're asserting against it. But there are a couple of tests that don't use it. So the test method becomes less readable because when you look at it, you start saying, oh, all these things matter? Do some of them matter to all the tests or not? And then you have to start dissecting the code again. So if you ever want to start refactoring these setup methods, it's going to be very hard because you don't know which dependencies, which tests depend on it. So if you have to use a setup method, make sure that you only put things in it that are applying to all the tests in the file. But if it's only for some of the tests in the file, I would just use a factory method directly in the test. Actually, I don't like using setup methods at all. I would just put the factory method most of the time and create the spy for each test. I find that it's more readable, and then the reader of the test doesn't have to look in multiple places to understand what's going on. And while we're at it, I don't think it's a great idea to test multiple things in the same test. I think that it makes the test name very, very generic. So maybe in jQuery, that's the pattern that has evolved. But I don't think this is a good pattern for use in every other framework as well. I think that if you have such a short test, but you're testing, look at the name, redirecting using redirecting in action prevents implicit render. I'm not sure what prevents implicit render means, but if we look at the asserts, we say that the Batman current app subview's length is 0. Maybe that's what prevents actually means. But then there is, I'm making sure that the navigator redirect was called. Now, interesting questions. Why do I care that it was called? Is it just an internal implementation? Possible. And then I don't need to assert on that. I only need to assert on the end result, which is the length is 0. Because then, if I don't need this line, then tomorrow I can remove all these calls. As long as the end result is still 0, my test will not break. But if this is important, if indeed this method that has 2 end results, which is possible, a method can have multiple end results, but each end result should be tested separately and have a good name. Then I would have a different test that says that when you call this, it calls navigator redirect, for example. But I would separate it, because in this case, if one of them fails, I'm not sure if it's actually a problem or not. And sometimes, especially in the unit testing world, people assert on mock objects just because they can, but doesn't mean they should. And when we look at all these things together, we find that we have those 3 pillars of good unit tests. They have to be readable, they have to be maintainable, they have to be trustworthy. If you don't trust your tests, you're not going to bother reading them. If you can't read your tests, it's going to be very hard to maintain them. And if you can't maintain your tests, you're never going to get them into any kind of a trustworthy states when they start failing. Thank you very much, and if there are any questions, we have a few minutes. So, when will the 2nd edition be released? Some questions about my mother, and hey, some people got the joke. Okay. Does the regulator have a future? Nobody knows what the regulator is except me and that guy. Okay, the 2nd edition should have been released this month, should be released this month. You say that only third parties should be mocked. What about when testing against your repository? I often find that I want to check that my repository was called in a specific way. I fully understand. If you do have a repository and your tests do have to use some kind of database, then I would say don't do unit tests on it. I would never create a mock object of a database and prove that some SQL query was actually called. And the reason is because the repository also contains a piece of the logic you would like to test. For example, the structure, the schema, is an example of some of that logic. And so if you do have some kind of repository, I would use only integration tests to test the data layer against that repository, and I would put that in a separate folder. Otherwise, it wouldn't make sense. The test would be very, very brittle, and it still wouldn't prove that anything worked. You would have the perfect query passing in your tests, but if you got the wrong schema, your application will actually not work. Separating tests, integration versus unit tests. Do you use test categories, or should it be separate projects? I don't specifically use test categories. I find that the physical separation is a better pit of success. I have seen people use categories, but I like the physical separation. It gives me a physical bucket to look at. When I'm sitting with someone and we're pairing together, we have two projects, and then I say, okay, which project should we write this test in? What happens with categories is that you end up deciding, if you remember, which category this should really be in. And sometimes the whole point is that it's so important that I would rather it be a physical thing and moving things. But I have seen people successfully use categories, so I would say it's more of a personal preference than a specific problem with categories. I just always made sense to me to move things and then I don't have to worry about features of a framework or naming conventions of categories if that changes at any time. If there are no other questions, I would like to thank you. You can feel free to learn more about all this stuff and get some more videos at ourdevunit-testing.com, and you can always contact me on Twitter. I appreciate your time. Thank you very much.